Hello, you bald ape. You, right now, are sitting on a tail. Not a metaphorical tail. An actual, honest to evolution vestigial tail, fused, stunted, buried at the base of your spine. You are, in every meaningful evolutionary sense, a tailless ape. The question is, why tailless? And what if we weren't? This is the case file. Let's start with what you actually have. The coccyx, 4 fused vertebrae. Completely internal, maybe 4 centimeters long. It anchors several muscles, pelvic floor, gluteus maximus. It is not useless, but it is very clearly the leftover of something much longer. And occasionally, rarely, but really, a human baby is born with a true, fleshy external tail. It contains vertebrae. It moves. The evolutionary machine still has the blueprint. It just stopped reading it. So, how did we lose it? The answer involves one gene, one mutation, and 25 million years ago. In 2021, a team at NYU Grossman School of Medicine identified the specific genetic change responsible. One gene, TBXT. TBXT controls tail development. In mice, it determines tail length directly. Change how it's expressed, and the tail changes. The ape lineage, our lineage, acquired a transposable element, a jumping gene, that inserted itself into the TBXT gene and disrupted it. The result, no tail. Across the entire ape lineage, gibbons, orangutans, gorillas, chimps, us, all tailless. Same mutation, same cause. One accident, one jumping gene, and 25 million years of apes with nothing to wag. But was losing the tail an accident? Or was it selected for? This is where it gets interesting. The NYU team found something striking. The same TBXT mutation that removes the tail also increases the risk of neural tube defects. That's a significant trade. Lose the tail, but gain a meaningful risk of spinal defects. Evolution accepted that deal, which means losing the tail had to be worth it. The tail had to be more of a liability than a loss. Here's the hypothesis. Apes, unlike monkeys, moved to a more upright below-branch style of locomotion, hanging, reaching, climbing vertically. A tail becomes a liability when you're swinging under a branch, not running along the top of one. Below-branch locomotion also demands a shorter, stiffer torso. A tail at the end of a mobile spine is suddenly more hindrance than help. So the tail went. And it stayed gone as apes eventually descended to the ground and started walking upright. Now, here is where we open the hypothetical. What if the mutation never happened? What if, right now, in the 21st century, you had a tail? First, what kind of tail would it actually be? We have to extrapolate from our closest relatives. Monkeys with prehensile tails, New World monkeys, use them as a fifth limb. They grasp, support, anchor, but our ancestors, the ones who still had tails before the mutation, were Old World primates. Their tails were not prehensile. They were balance and communication structures. So a retained human tail would most likely have been a semi-prehensile balance and signaling organ. Not quite a fifth hand, but not nothing. How long? Scaling from related primates, a human tail would likely be somewhere between 40 and 60 centimeters in an average adult. That is roughly the length of your arm from elbow to fingertip. Longer than most people picture, long enough to be an actual presence in a room. Picture walking into a room and that thing clearing everything off the coffee table as you turn around. Now let's think about what this tail would actually be made of. Bone, muscle, nerves, skin. It would be a living, innervated, metabolically costly structure. It would extend the vertebral column, probably 5 to 8 additional free vertebrae, not fused, mobile, expressive. It would cost energy. Maintaining a vascularized tail is metabolically real. Every calorie you eat, a small fraction goes to the tail. And it would be sensitive. The tip of a tail, like a fingertip, would have dense sensory nerve endings. Stub it and you would know about it. Here is the body mechanics question. Humans walk upright. Bipedalism already demanded radical changes to our pelvis, our spine, our center of gravity. A tail changes that equation. A tail at the back adds a counterweight. Your center of mass shifts. Your whole gait adjusts. In practice, it would probably improve balance slightly, but it would also mean you'd naturally lean slightly forward to compensate. A very subtle but permanent change in your posture. Sitting down would be a problem. Or rather, every chair ever made would be a problem. Every chair, every car seat, every airplane seat, every sofa, every toilet, every bench. The entire built environment assumes a tail-free human. In a world where we always had tails, none of those chairs would exist in their current form. All of them would have a slot, a gap, a cutout at the back. Trousers would be different. Every pair of trousers, every skirt, every pair of jeans would have a tail aperture. This is not a trivial industry impact. The entire global garment trade, trousers, underwear, suits, wedding dresses, all redesigned around one additional anatomical exit point. Architecture changes too. Doorways and corridors are designed around a body that is roughly rectangular from behind. Add a tail, and you need more lateral clearance. Staircases, escalators, revolving doors. The tail becomes a real engineering consideration in crowded built spaces. Transport. Cars would need larger boot space, not for luggage, just for seated drivers with tails clearing the back of the seat. Or, more plausibly, tail-bearing humans would have developed entirely different resting and transit postures. Less seated, more crouching, more perching. Now, here's the part that gets genuinely strange. What does a tail mean socially? In every tail-bearing mammal we know of, the tail is an involuntary social signal. Dogs wag. Cats puff. Horses swish in irritation. A human tail would likely be the same. Involuntary. You would not choose what your tail does any more than you choose your blush. Every job interview, every first date, every poker game, your tail broadcasting your emotional state involuntarily to everyone in the room. We already leak enormous amounts of social information through microexpressions, posture, pupil dilation. A visible tail would just be the loudest possible version of the same thing. There is a question of whether we would have evolved more sophisticated tail control. Voluntary muscles overriding involuntary signals. Humans are unusually good at suppressing body language, but at the very least, during childhood, during emotional peaks, during sleep, the tail tells the truth. Every time. What about attraction? Every tail-bearing animal uses tail position and motion in mating signaling. A tailed human species would almost certainly have developed tail-based courtship signals. The equivalent of a smile or a confident posture, but bigger and impossible to fake. The fashion implications of tail expressiveness are enormous. Every culture on Earth would have developed tail aesthetics, tail grooming, tail jewelry, tail wraps. Cultures would differ. Some would celebrate a raised tail as dominance. Others might view it as indecent. Tail suppression garments, the tail corset, would exist. Religion. Every major world religion would have a completely different relationship with the tail. Purity, sin, spirit, status. Art history looks different. Every portrait, every statue, every painted saint, the tail included, the tail position meaningful. Now let's return to biology. Because there's a harder question hiding underneath all of this. Would we have been as cognitively successful with a tail? The metabolic brain argument says the human brain is extraordinarily expensive. About 20% of our caloric budget, despite being 2% of our body mass. The body runs on a caloric budget. Every structure costs. A long vascularized muscular tail is not free. Some researchers have argued that losing costly anatomical structures, tail, body hair, some gut length, freed up metabolic budget that could be redirected to expensive brain tissue. This is speculative. The tail's caloric cost would have been modest, a few dozen calories a day probably, not enough to single-handedly explain encephalization, but small advantages compound over millions of years and millions of generations. 50 calories a day across 1 million years is not a trivial sum. There is also a locomotion argument. Bipedalism was already a high-wire act. The human spine is a compromised structure not elegantly designed for upright walking, but jury-rigged from a quadruped spine. Adding a tail to this already stressed system might have created structural problems at the sacrum, the junction point where tail meets spine in a biped walking on two legs all day. Which is why, in the parallel world hypothetical, tailed bipedalism would have driven its own evolutionary adaptations. Different pelvis geometry, different sacral angle, different spinal curvature. Evolution does not stand still. A species with a tail that walks upright for 1,000,000 years would not look like us with a tail glued on. It would have co-evolved around the tail. Let's do the full scenario. Paint the picture. What does the world look like right now today if we kept our tails? Cities are wider. Every corridor, every subway carriage, every cinema row, all designed with lateral tail clearance in the standards. Public transport has tail rail hangers. Vertical loops at standing height so commuters can anchor their tails while standing, freeing both hands. Sports are completely different. Gymnastics rewards tail control. Swimmers with longer tails have a propulsion advantage. Every sport's rules account for it. Medicine changes. Tail injuries are among the most common presenting complaints in emergency rooms. Tail fracture is a recognized orthopedic specialty. Tail lice, tail grooming rituals, tail hygiene products. The entire shampoo aisle has an extension. Social grooming, which primates do constantly, would have survived far more strongly in human culture. Tail grooming as a social bond. You groom mine, I'll groom yours. Language, spoken language, would still exist, but body language would be richer. Tail position would carry a vocabulary of its own. Cultures would have named tail positions the way we name facial expressions. There is a darker note. In every primate society, tail position is used to enforce hierarchy. Dominant individuals carry tails high, subordinates lower, or tuck theirs. In a world of tailed humans, the power dynamics in every room would be even more visible than they are now. The boss's tail, the intern's tail, everyone reading each other constantly. Whether this would have made human societies more honest or more anxious is a genuinely open question. We already have enormous trouble with involuntary emotional leakage. Blushing, trembling, voice breaking. A tail just turns the volume up. Now, a question worth sitting with. We didn't just lose the tail, we lost the genetic infrastructure for building one. Almost entirely. When the NYU team reactivated tail-building genes in mice, the mice grew tails again. The blueprint is still there, dormant, waiting. In principle, the deep genetic program for a vertebrate tail exists in your genome right now, silenced, expressed briefly in your embryo at around 4 weeks gestation, and then switched off. You had a tail. Every human who has ever lived had a tail for approximately 1 week as an embryo. Then the developmental program terminated it, reabsorbed the cells, and left you with 4 fused vertebrae and no explanation. The evolutionary question is not just why did the tail go? The question is, why did everything else stay so recognizably primate? We are not a novel animal. We are an ape with a particular set of modifications. The tail is just the most visible deletion, and the loss of the tail coincides with, but probably did not cause, the downstream cognitive explosion that produced language, culture, and self-important behavior of all kinds. The real lesson of the tail is not that we lost something useful, it's that we are built from compromises, accidents, and jury-rigged solutions, and it mostly worked. You are, when you really look at it, a bald ape that stumbled into consciousness and decided to build cities. And you did it with a broken spine and no tail. That's not a small thing. It's actually remarkable. But it's also exactly as absurd as it sounds. To summarize what we actually know. 25 million years ago, a transposable element disrupted the TBXT gene in the common ancestor of all apes. The tail was lost across the entire ape lineage. The mutation also increased the risk of neural tube defects, meaning losing the tail cost something. Below branch locomotion in the ape body plan made a long tail a hindrance. The mutation was selected for, not merely neutral. In the hypothetical where we kept it, every chair redesigned, every pair of trousers rethought, every room wider, and a constant involuntary social broadcast from your lower back. We are better off without it. Probably, almost certainly. The coccyx was reviewed and found surplus to requirements. Case, reluctantly, closed. If you found this genuinely interesting, which as a fellow ape, you should, subscribe. There are more case files open, more strange things about being human that deserve a rigorous look. The ape files? We take the question seriously so you don't have to pretend you weren't already thinking it.